Okay, this is to sort of help you a little bit with quiz 2-2, the at-home quiz. Now, I'm going to suggest to you here that you probably don't need to sit through all the problems, especially towards the end. But the first few problems here that you see the stars beside, you'll see those in just a minute. I tried to put those first because there's going to be some issues that maybe that we haven't seen come up yet. Now, I've started off this page to kind of maybe clear up a few things that might throw us off a little bit. And so what I'm looking at is the idea of the canceling out. And so if we look at these, most of the time, like for instance, when I do inverse sine of the sine of something, the sines would cancel out. And the same would go for the rest of these. But remember, that only works in certain quadrants. So when I take, like on this first one, the inverse sine of the sine of just some quantity right there, well, the sine of whatever quantity this is, and the same thing would be true for tangent also here. So I'll put those together for a reason. You remember that quantity, before that has to happen, has to be in between the fourth quadrant to the first quadrant. Or a different way of writing that would be that it has to go from negative pi over 2 to pi over 2. And so those quantities have to lie in those ranges. Now, for cosine, cosine goes from the first, or inverse cosine here. So this quantity of cosine of whatever has to lie in the first or the second quadrant. And the different way to write that would be it has to lie from 0 to pi. Now, let's look at the second column and look how this is kind of different when I kind of flop the inverse. And so in this case, what I'm looking for is that the inverse sine or cosine or tangent of whatever I'm taking of, that's where I need to check here. So what I need to check in these are these values here. And so again, the value that fell in this one and this one for sine, for inverse sine, and for inverse tangent would have to fall in between negative pi over 2 to pi over 2. And so if it didn't, those would not cancel out. So, you know, if long as they lie in that quadrant, in a correct quadrant here, these cancel and they're easy problems. But when they're not in the correct quadrant, it kind of opens up a can of worms there. Now, for the case of inverse cosine, so just like the other one, but just this value here, whatever that value might be there, has to lie in the first or second quadrant there again, which would mean it would have to go in between 0 and pi. Okay, now let's take a look at some of these problems here from this quiz. Okay, so now this first problem, notice I put a big star beside this one. I don't really think we've encountered something like this, although I think that you could probably figure this out. Now, let's look. This is an inverse tangent problem, and so the best thing that could happen is that those would cancel out, and then my answer would be 11 pi over 12. But remember what we just went through here. We're saying that this value, that the tangent of 11 pi over 12 has to be in either the fourth or the first quadrant, okay? So it has to lie in between, we said negative pi over 2 to pi over 2. Okay, so that's the fourth to the first quadrant. Now, 11 pi over 12 might throw us off a little bit because that's not on the unit circle, and that's why I'm kind of making a big deal about this. So I want you to try to imagine where 11 pi over 12 is. Okay, so let's think about this. We know that at that location, that's pi. And so 11 pi over 12, or let's think of this as pi, which would be 12 pi over 12. Okay, so 11 pi over 12 would be pretty close to that right there. And so we're looking at in the second quadrant there. Now, so notice what inverse tangent can't be in the second quadrant. So I've got to really modify this. And so what I got to do is I have to move to a quadrant that I could work with. Now, I couldn't move to the first quadrant, and the reason why is because tangent in the second quadrant here is negative. So really what I have to do is move to a quadrant where tangent is also negative. So I can't go to the first quadrant. So I would have to use a reference angle in the fourth quadrant. Because remember, tangent here, inverse tangent has to go from the fourth to the second quadrant. So what I'm going to do is use instead right there, what I need to think about is what would be a reference angle there. And so if this is, let me kind of erase this and start over for you. If this is 11 pi over 12, and we thought of this as being 12 pi over 12, which would be pi, that would make this reference angle right here pi over 12. And so now what I need here is, again, the angle to be in the correct quadrant. So for tangent to be negative, it would have to be, again, in the fourth quadrant. And so I would draw a reference angle there. And so notice that reference angle, since it's going in this direction, and we've said this before about the fourth quadrant, that this would have to be negative. So this would be a negative pi over 12 right there. And so that's where that angle is going to be. So really what we should look at there is doing this now finally, that the tangent now of the inverse tangent of, instead of 11 pi over 12, we would say negative pi over 12. Now we can actually do that, because negative pi over 12, see, the inverse tangent of negative 11 pi over 12 is in the fourth quadrant. And so now they can cancel. All right, so that one was definitely different there. And so the idea is that this, again, was not in the right quadrant. So I had to relocate the angle by using the reference angle. I'll try to maybe come up with another video here with maybe another problem like this. Be sure that you understand this problem. If you don't, please call me over and ask me. All right, next one. All right, this one's a little bit different, although I really think we could figure this one out. Now, this one's got inverse cosecant of negative 2 square roots of 3 over 3. Now, what I'm going to do about this one, they really didn't give us any of these with inverse cosecant. So what we can do here, instead of finding inverse cosecant, we could just find inverse sine instead, but not of the same quantity. And I think you could figure this out here. We would find the inverse sine of negative 3 over 2 square roots of 3. And so we just do the reciprocal identity there. Now, let's rationalize that, and it's going to pop up to something that we actually know. So if we rationalize and do this here, okay, this will give me now inverse sine of negative, and then on the top I'm going to have 3 square root of 3. On the bottom, picture square root of 3 times square root of 3 is 3, and times 2 would be 6. Okay, now I can reduce that. So now this would be the inverse sine of negative square root of 3 over 2. And so we're looking for, where is the sine negative square root of 3 over 2. Now recall, remember we can only look in the fourth or the first quadrant here. Okay, so let's see if we can find that value. Where is the sign? Where is the y coordinate? Negative square root of 3 over 2. And so right there. And so that angle measure there is 5 pi over 3. But recall, I'm not going to call it 5 pi over 3. I've got to do it as a negative angle there in the negative direction. So that would actually be negative pi over 3. So I wasn't sure that we maybe covered one like that, but I thought with the idea of the reciprocal here that you probably would have figured that one out. Okay, now the next one's just very, very similar here. And so you're doing inverse cotangent of negative square root of 3 over 3. And so what we could do with this is just find inverse tangent of the reciprocal, which would be negative 3 over square root of 3. Okay, now kind of recall here that we had an issue with inverse cotangent, that inverse cotangent and inverse tangent didn't work the same way, sort of. So remember the idea that inverse cotangent was like cosine in the fact that it just went from the first to the second quadrant. And so we're going to have sort of that quadrant disagreement. So let's see if you can kind of recall what happened about how we modified our answer. And so remember we had that one video that day, that the video that I didn't do that I showed you there, where we had the angle that was somewhere right in here as was supposed to be the inverse cotangent, but then that lied in quadrant 4. So what we had to do was find the reference angle over here. And so recall, to fix that, all we had to do was add halfway around the circle. So all we had to do there was add that pi. And so that's what I'm going to have to do in this case here. And so I'm going to find out what that angle is there, but I'm going to have to add pi to that. Now, inverse cotangent is the only funny one that is like that. So when I have inverse cotangent, we had that calculator problem that day where we had to do that and we had to modify it. That's the one that I told you about. Miss Monahan didn't realize that either. And so the idea with inverse cotangent there, if I'm going to use inverse tangent to find it and it's negative like that, I have that quadrant disagreement from the fourth quadrant to the second quadrant. And so I have to add pi to that for it to work. Now, let's see what this angle is now. So where is the tangent? Negative 3 over square root of 3. Now, I'd probably rationalize that. So let me just take a minute here to rationalize. So this will give me negative square root of 3 over 3 over 3. That would cancel. So that's just going to give me negative square root of 3. So now I'm going to do inverse tangent of negative square root of 3 plus pi. Now, if we've got our tangents memorized, especially in the first quadrant, then this is pretty easy. If we don't have our tangents memorized, then we're going to have to do a little bit of trial and error. So recall here, like in the first quadrant, at 60 degrees, or at pi over 3, the tangent value there is square root of 3. Now, if you really didn't, realize that, you'd have to say, well, how do I find tangent? I do sine over cosine. And so sine over cosine there will give me square root of 3 over 2, and then over cosine, so times 2 over 1. And so that gives you square root of 3. Now, what we're looking for, though, is a negative square root of 3. And so that would just be down here at 5 pi over 3, or what we could say there is that would be in terms of a negative angle, since we're doing inverse tangent, that would be negative pi over 3. So now I have negative pi over 3, and I have to add pi to that. Okay, so remember, what's wrong with saying negative pi over 3 here is negative pi over 3 is in the fourth quadrant. And cotangent can only go from the first to the second quadrant. So I have to relocate the angle using that reference angle idea or by adding pi. So if I add pi to that, I'm going to just write that as pi over 3 plus 3 pi over 3. And so that would give me, finally now, 2 pi over 3. So notice at 2 pi over 3, it's in the second quadrant, so that's okay for cotangent or inverse cotangent. And if we wanted to check it here, what we could do, you think about how would we find cotangent? We would do cosine over sine. So we do negative 1/2 divided by square root of 3 over 2 and check that. All right, that was a little bit different from what we're used to. It kind of took that calculator problem and expanded it to a unit circle problem. Now, let's go to the next one here that's a little bit different. I've left off the last choice. I don't think the last choice was the correct answer though. So this one was just a little bit of a different identity. I don't think we maybe saw one that was even similar to this one. But here again, I really think you could figure this one out. I'm just doing these just in case for you. Now, I'm pretty much going to do this one without working it out. I'm just going to look at the choices. So first thing is I'm going to look at the last step here. And so let's see if we can kind of tell what went on in this last step. Now this person got really creative with this. It's kind of hard to tell what they tried to do, but it seems like they tried to maybe do some canceling out there a little bit. And so they're going from cosine squared u plus 1 over sine u times cosine u plus 1 over sine u plus 1. And so I think what they tried to do there was maybe do some canceling out. I'm not quite sure how that they're getting that, but I don't really think that's working out. I think what happened here is they're doing this. And so what they're saying is this would cancel to a cosine. Not sure how they're getting the negative sign on that. But that's not working out. So that wouldn't be valid there. Now, let's look at choice B on this one. And so on choice B here, let's look at the last step. So on the last step, you kind of have to follow me here. They're going from this down to this. It took them 2 lines to put it there. And so notice in this case, I think what they're doing there is they're canceling out a cosine. And so the cosine, the square would cancel there with that cosine, and there's the negative. So that made sense there. Now, on part C, notice it's basically the same thing that they did in A, which did look like it made maybe a lot of sense here. This time they had sine squared minus 1. Now that one does, I'm sorry, okay, I'm looking at the wrong step. Let me back up here. I was looking at the third step instead of the last step, so let me kind of back up. Now, so basically it looks like the same thing they did in choice 1, or I'm sorry, I can't get it straight, choice B. So choice B and C sort of have the same last step. Now, choice D was a lot like choice A in the fact that the last step didn't make any sense. Now, so we've narrowed it down here to B or C. Now, let's look at the first step in B and C. And so one of these is not going to make sense here. All right, so in my first step in choice B, kind of take what they're doing here. They're writing tangent of u as sine of u over cosine of u, and they're writing secant as 1 over cosine. Well, that's valid. Tangent is sine over cosine, and secant is 1 over cosine. All right, let's see what they're doing in choice C now. So I believe choice C here, they're doing the same thing. So tangent of u minus secant of u, so they have sine of u over cosine of u minus 1 over cosine of u. So they've got the same step there. So what we need to do is go to the next step, and this is probably going to be sort of a difficult one. And I think what they're doing there on their next step is probably finding a common denominator with that. So notice they've got already common denominators there. Both of them have cosines of u, so the next step looks the same. So they're just taking sine u minus 1 and just putting both of that over cosine right there. And so that step is actually the same. So now we're down to looking at this idea from going from this step to this step. Now, this is what's sort of new to us in this problem. They're using a strategy here that's called, that I didn't introduce to you here, it's called a conjugate strategy. And so that strategy is to do this. When I see something like cosine of x minus 1 over something, really wouldn't matter, what I can do there is multiply by the conjugate, which would be cosine of x plus 1. And so the only thing is I would have to do this to the denominator also. Now, why would someone want to do that? And that's legal there because really you're just multiplying by 1. The idea is you're coming up and making the problem give you a Pythagorean identity, because cosine of x minus 1 times cosine of x plus 1 would give me cosine squared x minus 1. And if you look at that, that's actually some sort of Pythagorean identity there. Okay, so that's what they're doing in the third step. And there again, that's why I put a star on this problem here, to kind of show you that they're doing a little bit something different. Now, this is the step where they make a mistake. Okay, so you guys think about here multiplying this out. Notice the numerator is okay there. Or I'm sorry, the denominator is okay with that. It's the numerator here that they've got something different. And so if we do sine of u minus 1 times sine of u plus 1, there again, they're conjugates, so we just do first and last. Well, sine times sine is going to be sine squared, so that makes sense. But then negative 1 times 1 would be negative 1, not positive 1. And so they've made a mistake there. Now notice in this step, they do it correctly. Sine of u minus 1 times sine of u plus 1 would be sine squared u minus 1, like it's supposed to be. Now, just so you can get the idea, so that's definitely my answer there, is it's going to be C. The idea here behind the next step is this: they're using from here to here a Pythagorean identity. And so recall, we got, if we know sine squared plus cosine squared is 1, then the way we can get sine squared minus 1, which that has right there, is we can bring the 1 over. So we would have sine squared theta minus 1 would be equal to, and then the cosine would go over here. So it would be negative cosine squared theta. And so that's that idea on the next step on how that works. Okay, there again, what I wanted to point out was these two ideas right here. You actually saw it in the first choice there too, but the first choice didn't work. Is there doing what's called they're multiplying by a conjugate. And so the idea is if you multiply something by a conjugate there, you can get a Pythagorean identity. I noticed something too here, just kind of glancing at it. A had an incorrect first step. Let's see if you can kind of tell what happened here. So they're saying tangent is cosine over sine. That's not true there. So tangent would be, so that's another reason why the first step really didn't work there, if that last part kind of threw you off. All right, let's look at the next one now. Okay, this was another one here that I thought that probably didn't give you this one in your homework. Okay, so let's do like it says here, and let's multiply it, and then we're going to try to simplify. So the idea here is I'm going to take those two things there and just multiply that out. So we'd be using the full method. And so let me start multiplying that. So we'll have 1 minus, now we have a big parenthesis with a bunch of stuff inside here. So first, so I would do cosine times cosine there. And so that would be cosine squared theta. And now outside would be cosine theta sine theta. And then inside would give me a sine theta cosine theta. And notice the two middle terms are like terms. They're just in different orders there. And then sine theta times sine theta would be sine squared theta. Okay, so now we have all of this over sine theta cosine theta. Now let's clean this up a little bit. And so notice what I mentioned here. Those are like terms here. They're just sort of backwards. It's kind of like this. This one's xy and this one's yx. They're like terms. So if I added one of those to another one, that would get two of those. And so now this is going to simplify to 1 minus cosine squared theta plus 2 cosine theta sine theta plus sine squared theta. Now, I'm going to let you look at that a second and just give it a thought there. There's something else in here that should simplify to something. And there again, this is where I told you about those identities. You got to know them when you see them here. It's this idea. You have cosine squared plus a sine squared. And so that should really jump out at us here. That's just going to be 1. So now, if I simplify that, I have 1 minus 1 plus 2 cosine theta sine theta over sine theta cosine theta. Now let me distribute that negative sign. So notice that's why I was bringing those parentheses down, is so I could do that. And so notice when I distribute the negative sign, I'm going to get 1 minus 1, so that's just going to go away. And then this would be minus 2 cosine sine theta. So that's ended up going to be negative 2 cosine theta sine theta, because the 1s would go away, over sine theta cosine theta. Now you should kind of realize something nice would happen there. I'll get some canceling out because I got multiplication. I can do this. And so from all that, the answer is just negative 2. All right, there again, that's why I kind of put a star beside that one. I didn't really think we seen one, so I threw that one in there. Okay, the next one here, I think we've actually seen one like this. I didn't put a star beside it, but I wanted to look at it just in case, because I wanted to make sure you knew if you could do that or not. And so let's look at this idea right here. And so cosine, or inverse cosine of 1/8. Now, if we thought about that, 1/8 there, because that's positive, all right, and notice what 1/8 is pretty small here. This is the idea. We got to know, well, where is 1/8 on my unit circle? Okay, so basically, since we're just going to be looking in the first quadrant, and because that's positive there, then that's just going to cancel out. And really and truly, it's not because necessarily 1/8 would line the first quadrant, but if I do inverse cosine is in the first or second quadrant. And so anything in the first and second quadrant would have to be positive, and that's positive. So if I was doing the cosine of the inverse cosine of -1/8, then I'd have some trouble there. I couldn't cancel that out because that -1/8 would not be in the first or the second quadrant. But in this case, they do. So that just cancels out, and I got 1/8 there. And now, one other thing about, this problem with these two things canceling out is we can look at this value here, that would definitely lie in between from 0 to pi, because 1/8 here I think is about 0.125, and so 0.125 is definitely in between 0 and pi, which would be 3.14. Okay, so there again, you have to make sure that you would be in the first or the second quadrant before those cosines could cancel out. We look at two more sort of like that one. And so this idea here, you've got inverse cosine of the cosine of 5 pi over 7. So again, what do I have to ensure about here before I can cancel out is that the cosine of 5 pi over 7 has to be in the first or second quadrant, just the way that I had to make sure that 1/8 was in the first or second quadrant. Keep in mind, that's not a degree measure, that was a radian measure. That's why I said pi, 0 to pi there. And now, so cosine of 5 pi over 7, well, let's make sure that that's okay. Now, the reason why I'm including this one here is 5 pi over 7 is not on your unit circle, so you would have to realize what quadrant that's in. Okay, so notice we're in terms of sevenths here. So at pi, this would be 7 pi over 7. And probably so 5 pi over 7 would be over here in the second quadrant. And so because it's in the second quadrant, that makes it okay, because remember, cosine can go from 0 to pi. And so that makes that one okay to go and do this and cancel those out. Now, so here's another one here. If we're going to ask, can we cancel this out, or do we have to do something else here? Do we need to find a reference angle maybe to answer this question? And so there again, this value has to go in between here, the first and the second quadrant. And if you think about those values, that was from 0 to pi. And so what we're talking about again are the numbers 0 to 3.14. Well, 1.4 is in between there. 1.4 is in between 0 to 3.14. And so since that would be the first or the second quadrant, that would be okay, and then those would cancel out. So there again, you have to check the quadrant. So notice how on the inverse cosine, I look at that value there. When my inverse cosine was on the outside part, I looked at that value right there. Okay, I believe this is going to be all for the first video. The next ones I'm going to do on an additional video. I wanted to do, again, all of these that had maybe a little thing in it that we haven't seen before, and that way you didn't have to sit through the whole video to get to those problems.